Intervals. A set J, a subset of R, is an interval if whenever x and y are in J with x smaller than y, then every t satisfying x smaller than t smaller than y is in J. This definition allows the possibility that J is empty. For a comma b real numbers with a smaller or equal to b, the open interval denoted by this symbol is defined as the set of all real numbers x such that x is larger than a and smaller than b. The word open will be made clear later. Closed intervals. For a and b real numbers with a smaller or equal to b, the closed interval denoted by this symbol is defined as the set of all real numbers x such that x is larger or equal to a but smaller or equal to b. Since the sets are bounded, these are called the bounded open interval and the bounded closed interval, respectively. In addition, we also have half open or half closed intervals. For example, the set defined to be equal to the set of all real numbers x such that x is strictly larger than a but smaller or up to equal to b. And similarly, the set defined by this symbol to be equal to the set of all real numbers x such that x is larger or equal to a but smaller than b. These are examples of intervals. Infinite intervals. The set denoted by this symbol where a is any real number is defined to be equal to the set of all real numbers x such that x is strictly larger than a. Similarly, the sets defined by this formulas are called infinite open intervals and infinite closed intervals, respectively. These two are infinite open intervals, and here we have two examples of infinite closed intervals. The set of all real numbers, often denoted by this symbol, negative infinity to positive infinity enclosed by the parentheses, is also an unbounded open interval. We will see that R is also an unbounded closed interval. So R is a set which is at the same time an open interval and a closed interval. We'll prove this later.